We need complex numbers. We're going to be using it later. This is the way complex numbers work. I have this set that represents all of the real numbers. We've been working with those since 3rd grade, right? Now, I have another set that only has the number I in it. It's all that lives there. And so when you take these two sets together, this becomes a set called complex numbers. So complex numbers are the real numbers with the addition of an I. Now, what is I? Where did I come from? The definition of I is that I is the symbol that we use to represent the square root of -1. So anytime you see the square root of a negative number from now on, you can work with that because you can take the -1 part of it out and make it an I. Now I want you to notice that once I have to take the square root of -1 to get I, and I is not underneath the square root symbol anymore. Okay, it's kind of like the square root of 4 is just 2. It's not another square root of 2. Okay? All right. So if the square root of -1 is I, then what's I times I? That'd be I squared, right? Which is the square root of -1 squared. What happens with the square root and a square? They cancel out. So what has I squared actually got to be equal to? -1. Okay? Does that make sense? Square root of -1 times the square root of -1 is -1. Okay? Now I to the 3rd would be that -1 that's I squared times another I, right? I to the 3rd is the same thing as I squared times I. But I squared for the rest of your life, you're going to replace I squared with -1. That gives me -I. -1 times I is just -I, right? -1 times anything just changes its sign. Okay? So I to the 4th then is that -I times another I. Right? That's what I do when I multiply by another I. I just give it another one. So that gives me -I squared, because I times I is I squared, isn't it? Now what I just get through telling you we're going to do for every I squared you see for the rest of your life? Make it -1. So I've got the opposite of -1, which is +1. I'm sorry, what? No. Because I squared is -1 and I to the 4th is +1. So I've got I to the 1st power, that was I, right? That's, you know, square root of -1 over there to the side. I squared is -1. I to the 3rd is -I. Just kind of recapping what we just did. And I to the 4th is +1. Somebody tell me what I to the 5th will be. +1 times I. Look, did y'all get the pattern? If I multiply by one more I take the last answer and multiply it by I. Take the last answer and multiply it by I. So it'd be I. And then I to the 6th would be the last answer, which is I, times one more I, which would be I squared, which is -1. Anybody see anything happening? A lot of I's. Do you see any kind of anything there going on? Huh? There's a pattern. There is a pattern. Look at this. I started with I, and I went to -1, then I went to -I, and then I went to +1. And then I'm at I, I'm at -1. What would be the next one? I to the 7th. Last answer times I. -I. Let's go to -8. I mean 8, the exponent of 8. Take the last answer times I. Okay? Everybody see it's what we call cyclic in nature? The cycle goes through 4 steps, right? And then it goes back and it does the same cycle again. Then it goes through 4 more steps. So this is one of the favorite problems for them to put on the ACT test. They'll say, what is I to the 25th power? Okay, now you do not want to sit here and have to go through this, right? But if I take one more, if I go back one step, and instead of having 1, I have I to the 0, anything to the 0 power is always what? Anything to the 0 power is always 1. You need to memorize that because that's another one they like to put on the ACT test. Anything to the 0 power is 1. Does not matter what they raise to the 0 power. It is 1. So, if I have I to the 25th here, and this is my cycle, then what you can do is you can take 25 and divide it by 4, since it cycles through in 4 steps. And that'll tell me that I've gone through the cycle 6 whole times, right? Because at 24 I'd be back. Y'all with me? My remainder is 1. So that means I've gone completely through the 4 steps 6 times, and then I've gone 1 more step. So that's the same thing as I to the 1st. Whatever the remainder is tells me where I am in my pattern of 4. And I to the 1st is just I. So if you remember this little rule, this little trick, and how I works, if they give you this problem, it takes about 2 seconds. Remember, the idea here in the ACT is that you're supposed to be able to do 60 questions in 60 minutes or 40 questions in 60 minutes. I don't know what they've got going on with it now. But anyway, there are some problems on there that they expect you to do very, very rapidly, so that the harder problems you have time to work on. This is one of them that they think is a give-me question. So I just gave you the pattern. Take the exponent, divide it by 4. Look at the remainder. Then all you have to have memorized are these first 4. And if the remainder is 0, then the answer is 1. If the remainder is 1, the answer is. If the remainder is 2, -1. And if the remainder is 3, -I. You have it. Okay? Divided by 4. Anytime you raise an exponent by 1, it just means you're multiplying by that number again. So I to the 8th is I to the 7th times I. And I to the 7th we said was -I. So I multiplied by another I. You always take the last answer and multiply by I to get to the next one. So I to the 9th would be the last answer for I to the 8th, which is 1 times another I. So that's what I say. You can either do the whole table out to 25, because if you just keep using those same numbers over and over. But what it tells me is that I've gone through that cycle of 4 6 different times. I don't have to write that. I just need to know where did I end up in the last cycle, which is your remainder. All right, good deal. Yeah, 1 times anything is itself, right? Yep. Are we good with the definition of I? Now we're going to learn how to use I. When you work with I, you got what we call the standard form. standard form is A plus B times I, where A is the real number portion of this number and B is the imaginary number. So an imaginary number would look something like this, 2 minus 3i, or 1 plus 4i. Got the real number part in front, the imaginary number part second, with its coefficients. Now, when we add, subtract, multiply, or divide, what we do is we kind of hold these i's to be like x's. I know they're numbers, but we're gonna use them like we do with the square roots, where it's a number, but it's a like term, so I can combine stuff together. So on checkpoint 1, they give us some numbers to add together. Checkpoint 1. I'll be all right. And A, 5 minus 2i plus 3 plus 3i. Okay. So what you do is you combine like terms. So the real number parts get added together. So 5 plus 3 is 8. And then I got a negative 2i and a positive 3i that when I combine them together I get plus I. That's how you add them. So you just do like terms. Do the real number parts together and the imaginary number parts together, and you just combine them just like you do if it were an x. No. I is I. You're done with it. Yep, kind of like an x, but not like x. All right. Now subtraction. What do we have to be careful of on subtraction? Y'all have already had a problem with this. Got to make sure we distribute it out. So this is 2 plus 6i minus 12 plus I, right? Because I want to subtract off everything in that second set of parentheses. And once I do that, now I'm good. Now I just combine the like terms. So the real number parts are 2 and negative 12, so I get negative 10. And 6i and a 1i gives me, what? 7i, yes. Good. All right, so any questions about adding or subtracting? That's how you do it. Okay, the next one talks about multiplying. So checkpoint 2. We got 2 different kinds of multiplication. So we're going to do 2 different examples. All right, so on the first one, part A there, what do I need to do? What's your best guess? Distribute it. That's exactly right. So I'm going to do 7i times 2 and get 14i, and 7i times a negative 9i, which gives me minus 63i squared. Everybody understand? Now, at the very beginning of class, I told you for the rest of your life, every time you see I squared, you're going to turn it into what? Negative 1. So this is 14i minus 63 times negative 1. What does that give me? 14i plus 63. So what the I squared winds up doing is changing the sign of that term. Everybody understand that? You see it. Now that's not in standard form, because I need the I part to be last. So I need the 63 plus 14i. Good work. You're done with that problem. Nope. What do you think I need to do on the next one? I need to distribute the full, the big distributive, right? So I got 5 times 6, which is 30, minus 5 times 7i, which is 35i, plus 24i, minus 28I squared. Does everybody get that? Now what's the very first thing I'm going to handle? That I squared. I'm going to make that into -1, which is going to turn that last term into what? Plus 28. Excellent. Okay. Now, I got like terms I can just combine, right? So I just made that times -1, which just makes it positive 28. And so now the real number parts added together give me what? 58 minus 11I. Any questions? Nope, because the real number part's already in front. We good? All right, now, what's your question? Oh, you weren't finished. Okay, sorry. Now, before we talk about dividing, I've got to give you a definition. It's called the complex conjugate. So if I have a complex number, 4 plus 2i, then its complex conjugate is 4 minus 2i. Okay, same numbers, but you just change the operation between them. Okay? Same numbers, just change the operation. Now, we use the complex conjugate when we divide because we really don't divide. It's kind of like fractions. You know how you never divided by a fraction? You always multiplied by the reciprocal? Well, I'm always going to multiply by the complex conjugate. So if I have, let's just give us our checkpoint number 3 here. We have 5 plus 4i divided by 4 minus I. So we're supposed to divide and put this in standard form. Then what you do is you take the denominator and you multiply by the conjugate. So I'm going to take 4 plus I, but if I do it to the bottom, I've got to do it to the top. Okay? So when I divide, remember I'm not really going to divide, I'm going to multiply. So I'm going to do the distributive property or the full, whatever you want to call it. So I've got 20 plus 5i plus 16i plus 4i squared. Everybody see that? Y'all get it? That's over. Now, does anybody know why I use the complex conjugate? What's going to happen when I do the inner and outer terms? They're going to cancel out. That's why we do the complex conjugate. Always going to happen that the inner and outer terms are going to cancel out. So I don't even have to write them down. All I need is the first times the first, which gives me 16, minus the last times the last. Sure, you can write it if you want to. And then it'll just cancel out and just go to the next step. Okay? All right. Now, what do I need to do before I do anything else? Nope. Take care of the I squares. I want to take care of the I squares. No, I squared is -1 here, so that's going to make this. So I've got 20 plus 5i plus 16i minus 4. And so this is going to become -1, so I get 16 plus 1. Now I combine like terms, so I've got 20 and minus 4 gives me 16. And then the 5i and the 16i gives me plus 21i over 17. Now that's not exactly in standard form yet. To get that in standard form, you have to split it apart. So you get 16 over 17 plus 21 over 17 times I. That's actually standard form. Anybody got any questions? Then there's only one last thing in this section, and it's working with roots of negative numbers. So checkpoint 4. Square root of negative 27 plus the square root of negative 48. Now, square roots work like terms too. And so I can have a number times the square root, and I can use that like a coefficient to combine things. But the only time I can do that if the number underneath the square root is exactly the same for both of them. So right now, the way this is written, I can't do anything with this. But I can break this down, what we call rationalizing this. So I've got negative 1 times 9 times 3. Does everybody agree that negative 27 could be written as the factors negative 1 and 9 and 3? Yeah? And then we could do this, since everything's multiplied together, this does not work with addition. Everybody hear what I just said? If it had addition underneath there, it doesn't work. But since they're multiplied, I could take the square root of negative 1 times the square root of 9 times the square root of 3. I can actually take the square root of each part individually as long as the stuff's multiplied together. Now, what's the square root of negative 1? Square root of negative 1 is I. What's the square root of 9? 3. And I can't do anything with that square root of 3. So all that stuff just multiplies back together, and we traditionally write that as 3i times the square root of 3. We just put the I behind the number, but we don't put it behind the radical because it's not easy to see if it's under the radical or out if you just are not careful. Everybody see what I just did? Anybody confused? Yep. I'm trying to get it to simplify down, and I always try to pull out perfect squares to see if I can get some stuff to pull out. When I do this factoring thing, I want to figure out what it is in terms of perfect squares. Perfect squares being 4, because that's 2 times 2, 9, which is 3 times 3, 16, which is 4 times 4, 25, which is 5 times 5. Okay? So I come to this next one over here, and I want to think about what can I multiply together to get 48 utilizing my perfect squares. Well, I know I need that negative 1, right? Because anytime I got a negative, I put the negative 1 out in front. Can anybody? 9 doesn't go into it, right? 4 does. Okay. 16 is the biggest perfect square that will go into it. So 16 times 3. Not saying 4 is wrong, but you got to keep breaking it down until if you do it that way, okay? Now, I've got the square root of negative 1 times the square root of 16 times the square root of 3, right? What's the square root of negative 1? I. What's the square root of 16? And the square root of 3 stays the square root of 3. And when I multiply that all back together, rewriting it in standard notation, I get 4i times the square root of 3. Now they're like terms, and I can combine the coefficients. So what does that turn into? 7i times the square root of 3 is exactly right. So give yourself a list of perfect squares over to the side and kind of have it to look at, and look and see what's the largest perfect square that will divide evenly into your number That's going to shorten your work on this. Any questions? All right. You have your assignment.